Welcome to the Zebra Crossing. Today our guest is Sachin Jangam, who is a chemical engineer and expert in drying technologies, a researcher who has a keen interest in sustainability and related topics. He is an educator who is passionate about teaching and research in higher education with extensive experience in specialty chemicals, food, pharmaceuticals and bioproducts. Sachin Kaka has mastered techniques like heat pumping, dry freezing, spray drying and more. He also brings a bit of an experience in crystallization and filtration processes. Welcome to the Zebra Crossing, Kaka.
Thank you so much, Janhvi, for having me in Zebra Crossing. Thank you.
How are you?
I'm doing good. How about you?
Good too. So, can you tell me a little bit about your background and what you do?
Sure. So, Janhvi, I am a chemical engineer by profession. So, I did my Bachelor of Technology, followed by Masters of Chemical Engineering, and then I did my PhD in Chemical Engineering again, specifically in heat and mass transfer. I'm sure you must have heard about heat transfer in your school days. So I worked on drying technology as a specialized topic for my PhD. After that, I came to Singapore as a senior research fellow. I worked as a research fellow for about 3.5 years. And after that, I joined as a faculty member and I'm teaching chemical engineering and I'm currently a senior lecturer. So that's a short background about myself.
Okay. What motivated you to choose the education field and who are your role models?
Well, see, I never thought of doing higher studies. I mean, after my bachelor's degree, I started working in a company. I worked for a few months and then I got an opportunity to do masters. And my sisters really motivated me and pushed me to do masters, pursue masters. While doing masters, my supervisor during my master's studies, he pushed me to do PhD. And so yeah, I mean, I never thought of doing PhD, but yeah, I ended up doing it. And if coming back to your second question about role models, if you ask me, there's several people in my life, individuals in my life who have been my role models. And for role models, we don't have to go outside, right? In our family, our parents are our role models. So my mom and dad went through a lot of hard time, and hearing the stories from them really motivated me to do something in my life. Then both my elder sisters have been my real role models. Okay, and coming back to my education or my field, I have two big personalities in my life who have been my role models. The first one is Professor Arun Mujumdar, who was my supervisor. He has published 600 plus research papers in drying, in the field of drying and other chemical engineering fields. So he is one of my role models. And the second person is Dr. Raghunath Mashelkar, who is one of the greatest scientists from India. If you don't know about him, I would strongly suggest you to read a bit more about him as well. And how these people, encouraged me or they become my role model is, they have achieved so much in life, but still they are so humble. Even if you, see them, they will talk to very common individuals the same way they will talk to an expert in their field. So, that really motivated me in my life. And the third personality, I would say, or rather third category, is a sports person. I'm sure you have heard of tennis player Novak Djokovic, right?
Yes.
So he's like in recent year, he's one of my role models, and I even share his example with my students. The reason why I look at him as role model is his quality of not giving up. Perseverance is something, something that we can learn from Novak Djokovic. Okay, so these are few personalities, and of course there are many more, but I just named a few who have been my role models.
Amazing. So let's get to your research first.
Absolutely.
How do heat pump drying, freeze drying, spray drying and other techniques differ, and how do you use each of them?
Okay. So just to give you a simple example, right? Drying is essentially removal of moisture. It can be removal of water or it can be removal of some solvent from some products. Okay. So if you look around, right, yourself in this room, there is not a single thing that has gone through a drying process sometime in their lifespan, okay, when they are produced. So drying is extremely important technique used in industries to manufacture something. Okay, so in simple words, it's essentially removing moisture by supplying some heat. Okay, now the simplest example I can give you is pharmaceutical product, right? Either in a powder form, some medicines that you get in a powder form or a tablet form, they have gone through a drying process. Or you must have seen dried fruits, right, in market, or dried vegetables. So that's another example.
Okay.
Now you asked me specifically about the three techniques, right? If I recall correctly, heat pump drying, freeze drying, and spray drying.
Yes.
Well, heat pump drying in simple words is drying of something using dehumidified air. So the air con we use in our rooms, right? What is it doing? It is essentially cooling the air. So when you cool the air, it becomes dehumidified. In other words, it becomes dry. Its moisture is removed, and at the same time it is cool, right?
Okay.
But in heat pump drying system, we use this dehumidified but hot air. So dry and hot air to remove moisture from solid products. Okay. When we do this, the rate at which you can remove moisture is faster, and you can get very good product quality. That's heat pump drying. The freeze drying is something that is done at subatmospheric pressure. I'm sure if you have heard of vacuum, right? The concept of vacuum. So we use very high level of vacuum. Okay. Essentially, the pressure is below the triple point of water. So by doing so, we can retain the product quality. So if you go to market and if you find freeze dried, let's say strawberry or mango, the strawberry that you will see, the freeze dried strawberry, will be of the same size as original strawberry.
Yeah.
So it will look like an original strawberry. And if you just put it in your mouth, it will just disappear. So you get extremely good product quality.
Wow. Okay.
In freeze drying, and it is quite commonly used in pharmaceutical companies as well. And the spray drying is typically used to dry liquid. So if you start with liquid, I'll give you a simple example again. Let's say milk. I want to make a milk powder, but my starting recipe is milk, right? So I can spray the milk, convert that into fine droplets, and I can expose those droplets to hot air. When I do so, those droplets are converted to solid particles, and you get dried milk powder.
Wow. Okay.
So I hope that answers your question in simple words.
Yes. How do you choose which drying method to use for a particular product?
Interesting question. So choosing drying technique is an art. Okay, there are more than 400 industrial drying systems available in the market. Okay, that's a huge number, right? So the selection of drying technique depends on the product that you want to dry. For example, what form it is in, right? So if you are starting with drying of fruits, it's in a solid form. So you have certain types of dryers available. If you are starting to dry a liquid like milk, as I said, spray drying is one of the techniques. Or if you want to dry, let's say, powder form, right? Let's say paracetamol that we use as an active pharmaceutical ingredient in our Panadol, right? It is in a powder form. So you dry it using another type of dryer. So there are several criterion used. It also depends on how heat sensitive your product is. Like fruits are very heat sensitive, right? So you don't want to expose them to very high temperature, right? So there are several criterion available which can be used to choose the drying technique. So there is no single answer for that. Okay?
Yes. Can you share a success story where drying techniques were that you worked with have been used to make a product better?
Sure. So we, as I mentioned before, I worked extensively on heat pump drying system, and we have successfully used that to dry several fruit products like mango, for example.
Okay.
Mango has a lot of sugar, right? So drying mango is not so easy, but we have successfully used heat pump drying to dry mango. Or chiku. I'm sure you've heard of chiku, right? Or in biology, its botanical name is sapota. So again, that has a lot of sugar. It's very difficult to dry using an ambient or hot air. So we have successfully used heat pump drying system to do that. Or we have tried several biological products using heat pump drying system. So that's one example, I would say. And another example, industrial example, is we have modified drying systems, industrial drying systems, to reduce the energy consumption in drying systems.
Wow.
Okay, so that's a couple of quick examples I can think of.
Okay, so is sugar difficult to dry?
Well, if you have sugar, then drying, that means removing moisture. You don't want to dry sugar as such, right? I mean, what I mean is you don't want to remove sugar. What you want to remove is moisture. So when you have sugar, sugar will easily hold the moisture. Isn't that correct? Because sugar is hygroscopic.
Okay.
Right? So it will hold the moisture tight. So removing moisture from that product becomes a challenge.
Okay.
You understand?
Yes. What is your biggest challenge that you faced and how did you solve them?
Okay, so maybe I'll give you a couple of examples. One example from general, right? A general example from my life. So I studied in vernacular medium. So I'm from Maharashtra, and so as you. So I studied in Marathi medium. So when I went to junior college after my school days, I had a big challenge of conversing well with students who have come from English medium. Okay, it's not that I was not good in English. I had excellent teachers for my English subject in my school days. However, as a student from Marathi medium, I did not have that confidence. Okay, so that was the biggest challenge I faced when I entered junior college. But I had excellent teachers even during my junior college, and one of the teachers told me that, hey Sachin, you just need to have good confidence, that's it. So he started telling me some tricks. So he told me, observe students from English medium background and just see what kind of mistakes they make, but they speak confidently.
Yeah.
Right? And on the other side, I was quite good in, let's say, English grammar. So I started observing them and slowly I built up my confidence. So that one example I can tell. Second example from my research maybe. So when you're doing research, you get a lot of challenges. You face a lot of challenges, right? Sometimes your experiments don't go the way you want, or you don't know what to do, with your results, for example.
Yeah.
So the only thing I did is I never gave up. And of course, I had excellent mentors to mentor me during my, let's say, research work. So yeah, just talking to people, being patient helped me overcome those challenges.
Okay, wow. You mentioned before about crystallization and filtration. How do these two relate to drying?
Sure. So again, crystallization, I can put it in very simple words, right? Let's say if you start with liquid and you want to solidify that liquid. So crystallization process actually helps you to solidify liquid in a solid which is well structured. Okay. But when you are transferring liquid to solid, you still have some liquid left, right? And you have to remove it. So you can use mechanical techniques like filtration to remove as much liquid as possible. Okay. For example, our moms make tea or coffee, right? And they filter tea powder or crushed coffee beans, right? Then you get coffee. Yes. And you serve it to your guest or yourself. Isn't that correct? So that's a simple example of filtration, right? So you do crystallization, then filtration. So you remove maximum moisture or liquid using filtration, but still there will be some trapped moisture inside the solid particles.
Okay.
That has to be removed using drying. So basically crystallization and filtration are pre-processing steps before drying in most of the industries.
Okay, so
right?
It takes place before drying.
Absolutely. And if your crystallization and filtration is efficient, then your load on drying process is much lower.
Okay.
So you remove as much liquid as possible using filtration process, then you have less work to do, right, in your drying process.
Yeah.
Okay.
Yes. What new drying technologies are becoming more popular in your field?
Okay, so the drying field is quite established, I would say, but recently researchers have been using hybrid drying technologies like combining freeze drying with microwave drying, for example. So we know household microwaves are used to heat up food products, isn't that correct? So microwave has also been used to dry solid materials. Okay, so if you use freeze drying, which is a bit slower drying technique, and use microwave along with it, you can enhance the rate of moisture removal. So that way you can reduce the time required for drying. Okay, that's one example I can think of. Second one would be mixing or combining infrared radiation with air drying, or using superheated steam instead of air as a drying medium, or using nitrogen as a drying medium. So these are various techniques. So I would say hybrid technologies are becoming, something recent innovation I can think of. And we are also working on smart dryers, where you can sense the solid product quality during the drying process, and you can tweak the parameters used for drying so that you can reduce the energy consumption in your drying process.
Wow.
So these are some new ideas that are coming up.
Okay. Are there any environmental concerns about this?
Actually big, drying is one of the most energy intensive process in chemical industries. Energy intensive means uses a lot of energy, right? Because you are using hot air or hot drying medium, right? So you have to supply a lot of heat, right? If you use a lot of heat, that means you are burning some kind of a fuel to generate that heat, right? So if you are using drying process for a very long time, like some dryers require few hours to dry your product. And imagine you are burning some fuel for few hours just to dry something, isn't that correct? So a lot of carbon footprint, I would say, a lot of emissions coming out of the process because of drying process or drying techniques.
So are the hybrid techniques more environmentally friendly?
That's the goal. I mean, as I said, smart dryers or hybrid techniques are innovated basically to reduce the time required for drying process, right? Or optimize the parameters like temperatures, etc., used for drying process, so that you can reduce energy consumption, and in turn you can have lesser carbon footprint or environmental impact, in simple words.
Okay. Got it. What advice would you give to someone who wants to learn more about drying? Someone like me.
Certainly. So I don't recommend my students to just do Google search for any topic, right? But there are a lot of freely available interesting informations and very curated information available for common people to read about drying. So as I mentioned before, Professor Arun Mujumdar, who is my guru, who was my mentor, who is my mentor, and he is known as Drying Guru. Okay, so he started this project of ebooks, free ebooks. So we have more than 10 ebooks available on drying and related topics, which are available for anyone to freely download and read. So you can read those books and understand more about the drying techniques.
Wow, I'll make sure to check it out.
Certainly.
If I may ask, what motivated you to pursue research as your higher education?
Okay. Well, since my college days, I was like passionate about teaching. Okay, so my teachers during school days, college days, they really motivated me. They were one of the role models, as I said before, right? And when I was doing my engineering, I still remember our nights before exams. We used to have group discussions, and all of us will try to explain the concepts to each other. And I still remember helping my friends, during my exams. And I felt that yes, I'm good in explaining the things, to others. So that was like a starting point when I thought like I want to be a teacher. So after PhD, I was sure that I will be in academia, and I'll be teaching, next generations. Okay. So higher education, I would say research in higher education, that specific question, I always thought that we can do a lot of improvements in the way we teach or we deliver or we share our knowledge, so that students' learning will be better. And that is what I am doing even in my current role. I'm trying to improvise or come up with various techniques that can help improve student learning.
As a student, that's amazing to hear.
That's good.
Okay. If I may know 1 to 2 ideas that you've used so far.
Sure. So recently I have used something called as a hybrid learning or teaching techniques. So hybrid teaching means it's a combination of traditional way of teaching, like whiteboard teaching. Our days we used to have blackboards, but now we have whiteboards. So whiteboard teaching and mix of other techniques like flipped classroom. So in flipped classroom approach, what we do is we provide students recorded videos, like bite-sized videos, like very small videos, maybe 15-20 minutes videos. So they watch those videos before coming to the class.
Okay.
And during the class, we have more rigorous discussions about the topics included in those videos. Okay. And the third technique that I mix is, after the lectures, giving again them very short review videos. So this is one idea that I have been using. We call it as a hybrid teaching, okay, or hybrid teaching and learning experience for students. The second quick example I can think of is use of virtual reality, or basically use of technology in teaching.
Okay.
So we have developed a lot of online tools. We have developed one game which is not real the other games. It's related to some technical concepts.
Okay.
So developing those online games for students to understand certain concepts in greater detail, or as I said, use of virtual reality platforms to show students how, let's say, a chemical plant looks like. Rather than visiting in real, they can look at in a virtual world and understand the concepts better. So these are some ideas that I'm trying.
Wow. Okay. My last question for you is, what
Certainly.
advice would you give to your young audience?
Okay. Oh, that's a very interesting question, and that's what I do as a part of my job, current role. So I interact with students, who are doing university education, right? So the first general advice I give is, of course, hard work. There is no replacement for hard work, right?
True.
So, and there is always a reward for hard work, right? The second thing is not giving up, right? You do hard work, sometimes you don't get success, but you should be a person who will never give up, right? So perseverance is something that you should pursue. Then the third thing that I always tell my students is think out of the box. Okay, don't be fixated by something. Try to think out of the box and pursue your passion, right? And the last thing I would say is we should always think about we and S rather than being self-centric. Okay, this might be a blunt statement, but sometimes we do so, right? So I always tell students to think as a team, right? That always gives us success. So these are a few things I would like to possibly share through you to your young audience. I hope that helps.
Yes. That's all for today. Thank you so much for your insights.
No worries, Janhvi. Thanks for having me. Thanks.
And thank you for our audience today.
Thank you.